Hello, this is Environmental Psychology Part 2, Fossil Fuel Alternatives for Generating Power. This is a series of lectures that's associated with the New Jersey Offshore Wind Initiative. My name is Sean Duffy. I am a professor of psychology at Rutgers-Camden. So in the last module, I introduced this slide which shows the amount of different fuels that are used to produce energy, electrical energy in particular, from the year 2000 to the present day. And what I mentioned in the last module, but it's worth mentioning again here, is that the three fossil fuels that are most commonly used to produce energy are coal, natural gas, and oil. Now, crude oil is not often used to generate electricity. It's most often used in fuels for automobiles and for aviation. But the ones that are most associated with creating electricity are natural gas and coal. And you can see here that they've only been increasing over time. We tend to think that, in the world that there's a reduction in the use of these fossil fuels, but there's just been growing energy demand in general, which requires the use of these materials. Now, in the last module, what I went over is what are the implications of the burning of these fossil fuels. And clearly, climate change is one of the consequences that we are seeing the effects of today, and it's only going to get worse in the future. So the question really is, what alternatives are there to the use of fossil fuels? So eliminating the three fossil fuels here, the one source of energy that is most common is hydropower, which is when you connect a turbine to a dam and allow water to flow through that turbine, and that ends up generating electricity. It is a very useful way of generating electricity, but there are limitations to it as well. It actually has a long history. Right here, what I have is a picture of a water wheel, which has been used for centuries in order to create torque that is used to do things like drive mills, or to, whether it be a mill that's creating flour or a sawmill that is cutting wood. The use of water has been something that's been known for a long time. And so here what I have is a brief video to show you about how a hydroelectric dam works. Okay, so let me just hit play.
Hydroelectric power is
So,
generated using
on
the
the back
force of
the
falling water.
dam is where there's a
Water is
reservoir
held
of water.
behind a
And
dam,
this water
forming
is
an
exerting
artificial
a
lake
great
or
amount of
reservoir.
pressure against the wall
When
of this
electricity
dam.
is needed, some of
And
the
what
water in
they
the
have are
reservoir is
inlets
released
that allow
through a
water
water
to
intake in the
enter
dam.
the structure of the
Gravity
dam.
causes the
And
water
then
to
there's a
fall through a
tube that's
pipe
connected
inside the
to
dam
the
called a
turbine. It's called
penstock.
a penstock.
The
And the
falling water
penstock
spins a turbine, a type of
pushes
water
highly
wheel that
pressurized
converts the
water
water's
through the
energy
turbine,
into
which
mechanical
turns a
power,
generator,
which is
and that
located
in
at the
turn
end of the
creates
penstock.
electricity, which is then
When the turbine
moved onto the
spins,
grid.
it turns a metal
But
shaft,
as you can
which
see
goes
here,
up to an electrical generator.
one of the things
As
that
the
kind of
shaft
limits
turns, it causes the generator to rotate, producing
electricity is that you need to
electricity.
have a lot of space to
After
have a
flowing
reservoir
through
of
the
water.
penstock and across the
And you need
turbine,
to have
the
differences in
water
elevations.
continues into the
And
river
that
on the
becomes one
other
of the
side
key
of the
things that
dam.
limits the use of
Hydroelectric power is a renewable
everywhere.
source of energy.
So let me just
It's
stop
also
this
hydroelectric
and
power
move
is
on. So what I have here is a map of, in 2020, the hydropower map. Now, as you can see, there's a lot of hydropower projects in the west and in certain places on the east coast, but not very many in the plains because, again, you need to have water at different levels of elevation in order for hydroelectric dams to work, at least these big, huge infrastructure dams that create a great deal of electricity. But on top of that, what you also require is rain. Or other sources of water, whether it be runoff from mountains when the snow melts during the spring, or other sources of water that's always resupplying the reservoir. In areas where there's droughts, it becomes very difficult to actually have hydroelectric plants. And as many of you probably know from having watched the news recently, that the American West has been experiencing a large drought, until basically very recently. And I'll show you an image of that in a second. But again, hydroelectric power can really only work in certain locations. So here's the picture of the drought in Lake Mead. What we have is on the left the water level in 2001 and then again in 2015, and you can tell that the water level is much lower in 2015. Now, as I said in the previous slide, fortunately there was a huge snowfall in the year that I'm recording this in 2023, and so a lot of the runoff, the melting of the snow, really has helped reverse some of this. But that could be just a 1 year phenomenon, and that we could be back down to the same problem in the near future. But I just want to point this out, is that in order for hydroelectric power to work, you need water, and when there is drought or where there's not water available, there can't be hydroelectric power. Okay, so we talked about hydropower. Let's move on to the next one, which is nuclear power. Now, nuclear power is a carbon-free source of electricity in that you're not burning a fossil fuel. What you're doing is you're taking advantage of the fact that there are certain elements that are high in their atomic number that go through a process called fission, where they break up into smaller atoms. And what happens when this occurs is that it releases large amounts of energy. So the way in which a typical nuclear reactor is set up is that you have a reactor where you have uranium that is in a controlled environment in this reactor, and what occurs is that there's usually these control rods that are made of boron or some other material that absorbs neutrons. And when you take those control rods out, the chain reaction that occurs produces heat, and that heat is then used, goes through a heat exchanger, and it creates steam. The steam then goes and is pumped into a turbine room where there's turbines that rotate, and that is connected to a generator which produces the electricity. Now, we'll talk about this in a second, but nuclear reactions create a large amount of heat. And so one of the things that needs to occur is there needs to be a period of cooling. And thermal pollution is one of those things we don't often think about, that, well, if we were to pump hot water into a river or something like that, that won't be of a consequence. But in reality, you'd be killing a lot of, fish and other animals that happen to live and thrive on this environment. So nuclear power, as I said, uses fission to create energy by breaking the nuclei of uranium atoms, and that unleashes an incredible amount of energy. That energy, which is created in the form of heat, it's used to boil water. That turns the turbines and the generators. The advantage is that there's no carbon dioxide emitting, at least nothing's burnt. Of course, one can consider the fact that mining uranium also requires the burning of fossil fuels, because of all mining operations, usually they are burning some kind of fossil fuel in order to operate the machinery. But at the point of source of where the electricity is coming from, it's not producing CO2. Well, there are several cons. The first of being that radiation is dangerous. there's a history of accidents, whether it be in Pennsylvania, 3 Mile Island, or in the Ukraine, Chernobyl, or in Japan, Fukushima. There have been uh, accidents that really have affected communities and really have sort of cast a shadow on the future of nuclear power. Um, and inevitably, once this fuel is used up and it becomes nuclear waste, and that needs to be stored somewhere. And at present, most nuclear facilities actually store their waste on site because there's no national repository or place to put the spent nuclear fuel. At one time, they were going to put it into a mountain, but there was such community, rejection of that it didn't occur. So most nuclear power plants have on site a lot of containers of waste, and we need to, as a society, figure out what to do about that. Um, Another con is that nuclear energy really can be deployed only really in remote areas. You don't usually see a nuclear power plant in the middle of a city, like Philadelphia or New York. So they have to be kind of distant from population centers, simply because of the risk of an accident. Another con is that it uses a large amount of water. You need to have a constant water supply available to do nuclear energy in order to just cool down the reactors themselves. Because, as I said in the previous slide, there's this idea and risk of thermal pollution. I'm sure many of you, when you think of nuclear power, think of these structures. These are called hyperboloid cooling towers. And there's no nuclear anything going on in them. In fact, they're mainly empty space. And what happens is that really, really hot water goes to the top of these towers and drips down. And as it drips down, the water cools off, and then is collected at the bottom as water that you're able to actually put into a river or a stream. But the problem really with nuclear energy is that it produces just so much power, so much heat, that dissipating that heat becomes a real challenge. And that's why these structures, which you also can see these structures at regular power plants that need to cool down water, but the fact is that nuclear power produces unbelievable amounts of energy that need to be dissipated. And again, just, here's a little diagram of the Chernobyl nuclear power plant that went through a explosion in 1986 and requiring years of intervention. In fact, some of the isotopes that are released have half-lives of 10 to 20,000 years. So the site where Chernobyl exploded is going to have to be maintained and remediated for generations before anyone could ever live in that area again. So that's a risk, and so this is one of the reasons why you don't see nuclear power being installed these days. Here's actually a graph of the active reactors being constructed and installed or realized. And what you can see is that it really plateaued back in around 1980. That was in 1979, I believe. It was when 3 Mile Island occurred, where a release of radioactive material, small amount of radioactive xenon, in this town in Pennsylvania, caused a great deal of worry and concern. It didn't help that it came out a few days. This happened a few days after a movie about a nuclear power plant going under a partial meltdown came out as well, called the China Syndrome. But then Chernobyl occurred in 1986, and it flattened off. People are not wanting nuclear power plants being installed in their communities because of what they've seen happen with these disasters. So nuclear power is really kind of flattened off as a source of power in a lot of these plants that are reaching their operational end of their lifetime. It's they're going to be shut down, and we need to find alternatives to where these sources of power once provided electricity. We need to find alternatives. Okay, what about other ones like solar? Okay, solar energy uses the nuclear fusion which occurs in the sun, where instead of fission, where atoms are torn apart, in fusion, atoms are pulled together. So two hydrogen atoms become a helium atom, and that releases energy as well. And so light then travels through space and then reaches the Earth, and you can use that energy to either turn turbines in certain cases or directly by having solar panels that convert the photons into electricity. That's the far more common, but ways in which electricity have been used to move turbines have been. There's a couple of cases in California where they have these big deserts full of mirrors, and they shine these mirrors towards a central pole that has water in it, and that all of these mirrors reflecting all of this light and energy to this tower heats up water, and it's used to move a generator. But the vast majority of the kinds of solar energy that you see, like in your neighborhood, you might see a house that has a solar panel on the roof. That's a kind of solar panel that's producing electricity directly. Um, Now, of course, one of the pros of this is that there's no carbon dioxide emitted because there's nothing burned. And another pro is that it's relatively safe as a source of power, um, but there are cons. Um, it's expensive. The cost is decreasing, but these panels are not cheap. They also require materials, certain elements and chemicals in order to produce them, which also is a limitation because they can be, again, sourced by mining, but mining has its own affiliated problems. So the people are coming up with solutions to this problem. I just saw recently, I was talking with a scientist that was developing these microfilms that, whereas in the past you would need to have these huge structures on your roof, and, what this person was doing was coming up with, tiles for the roof, like the kinds of shingle tiles that you see on the roof, having some kind of a covering on that, and that producing electricity. So there's a lot of innovation going into this space, so we'll see things change over time. But the other major con, of course, is that it only works during daylight hours. You don't have the ability to produce electricity at night. So this is a map of sunlight by region of the U.S. And as you can see, in the American Southwest, there's a lot of sunlight. There's very few cloudy days in Arizona. But in the rest of the country, there's much less because of clouds. Like today, it's a cloudy day out. And that will reduce the amount of power that's able to be produced. So whereas solar might be advantageous in the American Southwest, a little bit less so in places that are really rainy, like Seattle. And also, what latitude you're at really affects things. So, the more closer that you are to the equator, the more light that you get throughout the year. Okay, the more north you go, such that you eventually are, getting up towards, Canada and above. Uh, there's less daylight during the winter months. So the amount of energy that you can produce decreases as you go higher and higher um, from the equator. So that becomes an issue as well. That there's just, as you go further north, there's less light to take advantage of and to convert into energy. What about other alternatives that, you know, that you rarely hear about? Well, there is biomass energy. So just like when you fill up your tank of gas and you see when you go to the pump, they say 10 or 15% ethanol. Ethanol is basically alcohol, and it's produced by growing corn and fermenting it and then producing ethanol, which you can substitute some of the gasoline that you have in your car with ethanol. Um, the problem with that is that that also produces CO2. So it's not it certainly, you know, makes it such that you're not using 100% gasoline, but it's not reducing the problem per se. Tidal energy. Um, this is a technology which you see examples of prototypes of this, where they will use the tide moving in and out or waves going up and down to generate electricity. It is a future technology. It's only in the experimental stage at this point, but it could be a source of energy in the future. Geothermal. Interestingly, they're coming up with new technologies that have been emerging from what we've learned about fracking. Fracking is a way of getting natural gas by going into the earth and setting off minor explosions, and that sort of cracks the rock, and you can extract more natural gas. In fact, people are using now this technology in order to extract more energy from the ground. And I will link to a video at the end that shows this process. It's a very interesting process. But geothermal traditionally has only been able to be used in areas where there's a lot of geothermal activity, where like places like Iceland, where most of the energy comes from geothermal because there's a lot of seismic activity up there that allows, volcanic activity up there that makes it such that you don't need to dig very far deep in order to get heat. And so that's very common in certain areas, and that again is produces no CO2. Now, another technology which is being talked about, but again, it's a future technology, is fusion, where we use the same process that's inside of the sun, where elements are fused together in order to produce energy. Now, as of this past year, there was a facility called the Ignite facility where they were able to actually do this, produce something like fusion. It was only a small piece of amount of material that was fused, but in 20 years this might be a technology that's available, and again that would be one of the safest because it would really release it would require such little material to produce a massive amount of energy. And so that's a future, but again, that technology doesn't exist today, but it's being researched actively right now. So the final alternative that I want to talk about, because that's going to be the main discussion of all of these modules, is the introduction of wind energy. Wind energy, in a sense, takes advantage of the sun and the fact that wind is produced by several sources of wind, but one of the more common reasons why wind exists is that there's certain regions of Earth that are warmer than other regions. And because of the nature of expansion of air in warm areas and contraction in cooler areas, wind is produced. I'm not a wind scientist, so I think that there's someone else that studies wind that's doing modules that will be very interesting to watch. But basically, wind comes from the way in which the Earth is heated, and so we take advantage of the sun's energy through the use of its effect on wind. And what we're going to do is get into the pros and cons in a later module of the use of wind, but I just want to point out this one graph here because it's a very useful one to compare the different sources of energy. So what we have here is a table that compares the habitat impacts of wind energy to other energy sources. And so what we have under habitat impacts, we have air and water pollution, global warming, thermal pollution of water, flooding of land, waste disposal, mining and drilling, and construction of plants. Okay, so when you're dealing with coal, we're having to deal with almost all of these. The one that we're not really that coal's not dealing with as much is the effect of thermal pollution. But all of coal, natural gas, and oil are polluting air and water, contributing to global warming. They are this problem of waste disposal. With coal, there's ash that needs to be disposed, mining and drilling, and the construction of plants. So all of that fossil fuels sort of have to deal with. Nuclear seems to, the problem is the thermal pollution. As I said, it produces a lot of heat that needs to be extracted. But also waste disposal with nuclear. Where do we put ultimately all of those tons and tons of waste that's produced over the years, the lifespan of a nuclear power plant? Mining and drilling. You need to get the uranium from somewhere, and that, and produce it. That is energy intensive and that's a problem as well. And you have to construct these plants, and nuclear plants tend to be very, very expensive. With hydropower, you have the one thing that's different than all the others is the flooding of lands. Like whenever you build one of these dams, you're producing a reservoir behind it that's going to rise over the course of time, and that takes away land. And often in the history of our country, a lot of that land has come from indigenous people and from people who live in poverty and have very little say over a big company or the government coming in saying we're taking your land and moving you somewhere else. So hydroelectric power, it's great, but it takes up a ton of room. But what we have is wind is none of the affiliated pollution. We have none of the problems with flooding, with waste disposal, for the most part. At some point, we're going to talk a bit about the recycling of the fan blades that are used in these plants. But really, the only major problem with wind is the construction of plants. Now, this is going to be the subject of many of these modules. Is going to be like, why do people have concerns about this? The construction of plants in their communities, and so that's going to be a big topic. But in order to summarize, in summary, all alternative sources of energy have advantages and disadvantages. And it is just unfortunate that there's no perfect solution to the problem of producing energy. It is something that many scientists have struggled for many years trying to come up with solutions, and there's no great solution. However, wind energy does have a number of advantages over other sources of alternative energy that do not contribute as much as fossil fuels do to climate change. So I think that in the future, wind is going to be an important part of a basket of alternative energy sources that can help mitigate the problem of climate change. So in the next couple of slides, I'm going to link to a few videos that you can choose to use or to skip, but there'll be a few excerpts from the PBS NewsHour. So I hope you enjoy them, and I look forward to seeing you in Module 3.